Hello all, welcome to lecture 3 on basic types of signals. So in the previous lecture we had dealt about different types of signals such as impulse function and unit step function. So in this lecture we will be seeing basic types of signals. So the first category of this signal is ramp signal. So ramp signal is denoted by R of t. R of t, where R stands for ramp. R stands for ramp. And it is defined as R of t is equal to t or 0. The condition is R of t is equal to t when t is greater than or equal to 0, and R of t is equal to 0 when t is less than 0. You can see here, when the time is greater than or equal to 0, R of t is equal to t. Next, it is 0 when t is less than 0. That is, with increasing time, the value of ramp signal is also going to increase. That is, at 1 it would be having a value of 1, at 2 it would be having a value of 2, and at 3 it would be having a value of 3. In likewise, if the time increases, the value of ramp signal is going to increase, which that's why this particular signal is called as ramp. That means the value is going to increase continuously with respect to time. And the area which is under ramp signal is also unity. That is, there would be almost no end for the area which is covered under the ramp signal. Why? Because the value of ramp is going to increase with increasing time. U of t is equal to integral 1 is equal to t is equal to R of t. Now, if you want to find the value of u of t, you need to differentiate ramp signal with respect to time. That is, d by dt of R of t is called as ramp signal. And you can see the area under ramp signal is unity. Now, coming to the next type of signal, parabolic signal. Parabolic signal would be having an equation which is equal to t square by 2 time square divided by 2 when t is greater than or equal to 0, and the value of a parabolic signal would be 0 when t is less than 0. Now here you can see the parabolic signal is defined as x of t. This x of t represents the complete signal, and t stands for the time, which is equal to t square by 2 when t is greater than or equal to 0. That is, from 0 the value is going to start, and it would be almost half of the t squared. Suppose you can say that the value of t is 1, at t is equal to 1, the value would be 1 by 2, that is 0.5. At 2, suppose t square by 2, that is 4 by 2, it would be 2. And at 3, suppose if t is equal to 3 seconds, 3 square by 2, its value would be 4.5. Likewise, it is going to increase in a manner of t square by 2. Next, in the basic types of signals, the next type of signal is signum function, and the signum function is denoted by SGNT, signum of t. And this signum function is, the value of a signum function would be equal to 1 where t is greater than 0, and it is equal to 0 when t is equal to 0, and it would be minus 1 when t is less than 0. That is, when the time is less than 0, its value would be minus 1, and at 0 its value would be 0, and if the t is greater than 0, that is, here the line had started exactly at 0, but it would be somewhat forward. So it would be 1 if t is greater than 0. Okay, this is called as a signum function. It almost encompasses the values from minus 1 to plus 1. Next one is exponential signal. And exponential signal is another type of signal where x of t, that is x of t is the signal, is equal to e power at, where e is the exponent. Okay, And the shape of the exponential can be defined by a. The shape of the exponential defined by a. If a is equal to 0, x of t is equal to e power 0. E power 0 is always equal to 1. And when a is less than 0, that is negative. If you say take the value as a is less than 0, x of t is equal to e power minus at. The shape of exponential is called as decaying exponential. It is called as decaying exponential. And if a is greater than 0, okay, the shape is called as rising exponential. Suppose if a is greater than 0, it is positive, a is less than 0, it is negative, and a is equal to 0, it is equal to 1. So here a is equal to 0, the value is 1 in this first figure. And in the second figure, a is less than 0. Okay, if a is less than 0, you can see the value is decaying. Okay, now a is greater than 0, it is called as rising exponential. Now, the next type of signal would be rectangular signal. Rectangular signal. These rectangular signals you would be watching in CRO whenever you are generating a square wave. Okay, basically by using function generator, we will be generating a sine wave, square wave, and a triangular wave. And you would be also studying the about the output of an integrator and differentiator, where you will be getting square waves and triangular waves. Okay, so suppose by using this function generator, suppose assume that you have generated a square wave. So let it be denoted as x of t, and it is defined as, okay, x of t is equal to a rectangle r by t. That is, this t stands for time period. T stands for time period. Now, this x of t is the function. Okay, and a stands for amplitude. A stands for amplitude. Okay, so here suppose see, here a is equal to 4. Here a is equal to 4. Here written as 4 RECT, r by 6. Now, why here you are getting 6 means, even though the time period is negative, you will be taking this time period and this time period, both these things under consideration. And here 3 seconds plus 3 seconds will be coming here as 6 seconds. Here t by 2 and here t by 2. T by 2 plus t by 2 will be coming as t, capital T. Now next, triangular signal. Triangular signal is normally any type of signal. By its name, we will be representing square signal in the square wave form and triangular signal in the triangular type wave form. So, it is also denoted with x of t, and it would be a into 1 minus t by t. 1 minus t by t, where t is the time period and divided by t is the total time divided by this particular time period. Suppose you can see x of t is equal to a into 1 minus modulus of t divided by t. Suppose modulus of t means this total time period divided by this capital T corresponds to the time period in this particular plane where we are considering it. Okay. Now next, here a is equal to, the x of t is equal to a into 1 minus t by 5. So this t is the total time period and 5 is the time period what here you are having. Now, sinusoidal signals. Sinusoidal signals, it is a signal which is in the form of a cos omega plus or minus pi, or omega naught plus or minus pi, or a sin omega naught plus or minus pi. So it may be having a sine components or it may be having a cosine components also. So there is no restriction for a sinusoidal wave. So this is the sinusoidal signal what we are seeing. Now, we had seen, till now we had seen different types of signals. And now let us see the classification of signals, how the signals are classified into different categories. Now continuous time signal, discrete time signal, deterministic and non-deterministic signals, even and odd signals, and periodic and aperiodic signals. Continuous time and discrete time signals we had already seen in the first few slides, where an analog signal would be having continuous values and a discrete time signal would be having values at that particular instant. Now we need to focus upon deterministic and non-deterministic signals, even and odd signals, period and aperiodic signals. Next, energy and power signals and real and imaginary signals. So, imaginary signals or real component and imaginary component will be there, and energy and power signals will be there. Now, as seen in the earlier slides, a signal is said to be continuous when it is defined for all instants of time. That is, if you are dealing with analog signal, you would be having continuous values for the signal, and it is called as a continuous time signal. And a signal is said to be discrete when it is defined at only discrete instants of time. That is, one particular instant you would be defining the particular signal, which is called as a discrete time signal. Now, the further classification of signals we will be seeing in the next lecture.